Hello dear students. So in the today we are going to discuss a numerical based on D'Alembert principle. So what is given in the numerical is a body of mass m is projected up a 25-degree inclined plane with an initial velocity of 15 meter per second. If coefficient of friction mu k is equal to 0.25, determine how far the body will move up the plane and how much time is required to reach the highest point. So this is asked in the numerical. Now you can see in the diagram here, yes, I have directly drawn the free body diagram. So a block whose mass is given here, yes, the mass of that block is m, and it is moving up a plane which is at an angle of 25-degree incline. Okay, so this is given. Now what I will do is I will show the block. Okay, I will show the inclined plane. Okay, now we all know that the weight is always concentrated at the center of the block, vertically acting downwards. So what do you have to do here is, yes, you have to consider the two axes x and y. Okay, so in this numerical, what I will do is I will consider an axis perpendicular to the plane, that is my y-axis, and x-axis is along the plane. Okay, so whatever calculations will be done, we will be with respect to these two axes. So mg, I will resolve it along this y-axis and x-axis. So I'll be having the two components of mg. Now the question arises, how much is this angle then? So in the given numerical, the angle of inclination is 25. So will be my angle of repose also 25 degree. Okay, so mg का component जो होगा that will be mg cos of 25. ओके वाई बिकॉज इट इज़ द एंगल ऑफ रिपोज. तो जिसके साथ एंगल दिया है हमेशा वो होगा आपका कॉस कॉम्पोनेंट. दैट्स वाई दिस कॉम्पोनेंट विल बिकम कॉस ऑफ 25 एंड द अदर कॉम्पोनेंट विल बिकम एम जी साइन ऑफ 25. इन दिस वे आई डिड रिजॉल्व द टू एम जी फोर्सेस. नेक्स्ट, in the numerical it is given that coefficient of kinetic friction, yes, it is 0.25. Why kinetic? Because the block is in the moving condition. Okay, so we always know that how is the frictional force? It's a resistive force acting always in the opposite direction of motion. So it is clearly mentioned in the numerical that the block is moving up the plane, so obviously my frictional force will be acting down the plane in the opposite direction. And what is the value of this frictional force? Yes, the value of that frictional force is nothing but coefficient of friction multiplied by its reaction. Okay, so coefficient of friction given is 0.25 and its reaction is n1. Now what is this n1 reaction? Okay, so mg, the component is mg cos 25 along y plane. So this box is being supported by this inclined plane. So wherever there is a support, there is a reaction. It means what? This inclined plane is acting a vertical reaction upwards on the block. So that is my reaction n1. Always you have to show while solving this numerical in the free body diagram. Okay, so I did show this n1. Okay, so frictional force is the product of that n1 multiplied by coefficient of friction. Hence we have completed the free body diagram, and in the given numerical it is stated that initial velocity of the block is 15 meter per second and final velocity is 0 because it is going to reach the highest point, means it is going to stop. So v is equal to 0. Okay, now we'll be using the conditions of equilibrium. First, summation of Fy is equal to 0. Now what are the vertical forces? Now many of the students tend to make a mistake in the numerical is they do consider the forces like this with respect to the horizontal plane, but always do consider the forces, yes, on y plane which is perpendicular to the incline. So whatever forces are parallel to this y plane, I will consider in the summation of Fy calculation. So there are two forces which are along the y plane. Yes, n1 is acting upward, so positive, minus mg cos 25 is acting downward, so negative, equated to 0. So hence I will get the value of n1, name it as equation number 1. Next, second equation is summation of fx is equal to 0. Now whatever the forces are acting along the x-plane or parallel to the x-plane will become my horizontal components. So what are the horizontal components now? 1, component of mg is horizontal. Yes, I will consider this as origin. So towards left negative, towards right positive. Okay, so this is acting towards left. So my mg, yes, sine 25 minus the frictional force is what? 0.25 N1 minus MA. Now the question arises, what is this MA? Okay, so in the introductory part of D'Alembert's principle, you must have seen that to show that the body is in dynamic equilibrium, always will be showing a D'Alembert's force in the opposite direction of motion. Now in this numerical, the block is moving up the plane, means the particle is accelerated up the plane. So to bring the body in dynamic equilibrium, I will apply a inertia force of S mass m into acceleration a in the downward direction. Body is moving upwards, so inertia force will be acting in the opposite direction, downwards. Okay, so that I have shown here, which is nothing but minus ma is also a horizontal force equated to 0. Hence simplify this equation and name it as equation number 2. Okay, now in equation number 1 already you have got the value of n1. Substitute that in the equation number 2 and simplify it. You will get the value of acceleration. Yes, that is minus 6.369 meter per second square. Okay, now we have done with the first part of the numerical. Now in the second part, it is asked what is the time required to reach the highest point. Okay, so how do I calculate the time? Okay, by using this equation, okay, v is equal to u plus at. V is given 0, yes, it reaches the highest point. U is given 15 plus acceleration we just calculated, substitute into t. Hence from this we'll get the value of time, t is equal to 2.355 second. Next, yes, we need to find out what is the highest point reached, means what is the highest distance, maximum distance covered by the block. Okay, so for that I'll be using this equation, v square is equal to u square plus 2as. So v value is given, which is 0. Okay, u is 15 square plus 2 into a into s. Hence we'll get the value of displacement of the block up the plane, which is 17.66 meter. Hence the numerical is completed. Thank you.